Now, before we get started with the electrical portion of our DVDs, we need to have a basic understanding how air conditioning works. Basically, what air conditioning is you're taking the warm air from inside the home and you're moving it to the outside of the home. It all boils down to you have basically two pieces of equipment. One is the air handler, sometimes I refer to it as the furnace, which will be located indoor of the home. It could be inside of a closet, it could be mounted up in an attic, or it could be out in the garage. The other piece of equipment is known as the condenser unit. It will be located on the outside of the home. Now, the three major components of an air conditioning system are the compressor, the condenser, and the evaporator coil. Now, the compressor, it's located in the outdoor unit and the condensing unit, along with the condenser coil. The evaporator is located on the inside air handling unit, called the A coil. Now, the function of the compressor is to keep the refrigerant moving through the system the entire time. The condenser's job is to collect the heat from inside the home and release it outside the home, whereas the evaporator's job is to cool the air inside the home. Air conditioning systems use refrigerants that convert from a liquid to a gas and back again to transfer the unwanted heat from inside the home to the outside of the home. Now, the compressor plays the role of moving the refrigerant from the evaporator coil to the condensing coil outside. Once this liquid reaches this inside coil, it evaporates and it turns to gas. When it turns to gas, it attracts heat from the inside warm air to the evaporator coil, which provides cool air for the inside of the home. When it leaves the inside coil, the evaporator coil, it's a low pressure, low temperature vapor gas. When it reaches the compressor will then squeeze this into a hot, high pressure gas and then flows to the outdoor condensing coil, where the aluminum fins on the condensing coil help dissipate the heat, and the outdoor fan motor pulls air from outside across the condenser coil and exhausts it away from the unit. That's why if you're outside and you hold your hand above the outdoor fan motor, if the unit is functioning properly, you will feel hot air coming out. That's you taking the unwanted heat from inside the home and releasing it to the outside. Now, when it leaves the condenser, its temperature is much cooler. When it goes into the top of the outdoor cooling unit, once this high pressure, high temperature gas enters this outdoor coil, the condensing unit, and the aluminum fins dissipate this heat, it changes from a gas to a liquid state again, lowering the temperature. Now it's going to be a high pressure liquid. Once it goes to the expansion device, which has a tiny little hole inside of it, it's a metering device, the liquid pressure then drops. Now it's a low pressure, low temperature liquid. Now it goes back into the inside coil, the A coil, turns to a vapor, removes heat from inside the home, and it starts the process all over again. Now it's a low pressure, low temperature gas to the compressor. The compressor squeezes the gas, turns it into a high pressure, high temperature gas. It comes to the outdoor coil. The fins on the outdoor coil help dissipate the heat. The outdoor blower motor pulls outdoor air through the coil, cooling it even more. When that happens, it returns to a liquid state, drops in temperature, but it's still a high pressure, high temperature liquid. until it gets to the expansion device, and all over again. Now this evaporator, this indoor A coil, it also serves another purpose. It dehumidifies the air. Because this coil is cooled by the refrigerant to a low temperature, usually this temperature inside of this A coil is around 35 or 40 degrees. The air goes through the coil and reaches dew point. Now what we're actually doing is collecting water from the air. Then down below this A coil in your air handling unit, you'll have a drip pan. And this drip pan will then have a pipe that flows underground outside your home to drain this water. Just remember, an air conditioner is only a mechanical device that collects heat from an undesirable location and conveys it to a more desirable location, namely from inside the house to outside the house. Now, a heat pump works just like an AC unit in the cooling mode, but in the heating mode, it causes the refrigerant to flow backwards. It takes the heat from outside, absorbs it into the refrigerant, and then releases it from the refrigerant to the indoor air. All we're doing is we're using a reversing valve to reverse the positions of the flow. On an AC unit, this inside coil would be the cold unit, and outside, the condensing unit would be the hot unit. Now all you're going to do is take the inside coil and you're now going to make it the hot unit, and the outdoor coil is going to be the cool unit now. And all you're doing, again, like I say, is using a reversing valve to change the flow, the position of the refrigerant. By reversing the flow of the refrigerant, the two coils, the evaporator and condensers, are reversed. The refrigerant now flows from the compressor to the indoor coil first, where the refrigerant now condenses and then flows to the outdoor coil, where it evaporates. You might be saying to yourself, how in the world am I going to pick up heat from outdoors when your temperatures, locally here, 25, 28 degrees have been the coldest. We're up north, you might be below zero sometimes. Well, R22 refrigerant actually boils at 40 below zero. So it can pick up heat from outdoors even if it's really cold outside. But now, because the evaporator coil is now working outdoors, there's a chance for it to ice up. Therefore, the system must go through a defrost cycle. To make the system defrost, the unit has the refrigerant flow just as it did in the cooling. So the reversing valve changes positions. Now you're in the AC mode. The outdoor fan cycles off and the refrigerant warms up the outdoor coil until the ice melts, and it shifts back into the heating mode once it times out and thaws the ice off the outside coil. The heat pump, when compared to electric heat strips, is approximately 3 times more efficient to operate. When compared to gas heat, they are close to the same. But local gas and electric prices dictate the efficiency of each.